Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about cement. So in this mail we discussed about composition of Portland cement and setting hardening of Portland cement. So first we discussed about cement. So already we know that cement is the most important construction material. Cement is the inorganic most important construction material. It is mainly used for construction of buildings, roads, etc. So here, for example, concrete. So concrete is most widely used non-metallic material in construction of buildings, dams, bridges and highways. So in this preparation of concrete, cement is the most essential bonding material. So which binds sand, rock when mixed with water. So cement is the most important construction material. It is mainly used for construction of buildings, roads, bricks, etc. So in this first one, preparation of concrete, in this cement is the most important essential bonding material. It is essential bonding material and it acts as a binder. So when mixed with water, it binds like sand, rock, etc. when mixed with water. So cement is generally it is our color is grey green or blue gray or grey green or blue grey heavy powder, and find its importance as a building material, and it acts as a binder. It binds when we mix it with water, it binds rocks or sand, etc., which are used for construction purpose. It binds all these ingredients which are used for the preparation of cement, setting and hardening purpose. So it can be described as a material possessing adhesive and cohesive properties. The most important property of cement is it has adhesive and cohesive properties. So what is the meaning of adhesive? So the molecular interactions, the interactions between two objects or two molecules. For example, that is one is cement and the other one is rocks or say sand, etc. So it is bonding interactions between two objects or two molecules is called adhesive and cohesive. That means one cement particle is attracts with another cement particles. That means both are having same molecular forces. So cement is having most important properties, adhesive and cohesive properties, and capable of bonding materials like stones, bricks, building blocks, etc. So cement has a property of setting and hardening in the presence of water. So it is called hydraulic cement. So the essential constituent of cement used for construction purpose are generally calcareous and argillaceous materials. Calcareous means calcium oxide. Argillaceous means it is a combination of silicates and aluminium. So cement is the most important construction material and it acts as a binder. So in this it is having most important properties, adhesive and cohesive properties. So when we mix it with water, the setting and hardening, the time taking means it is the strength of the cement is increases. So during setting and hardening in the presence of water, so the cement is also called as hydraulic cement. So the essential constituent of cements used for construction purpose are the compounds involved in this calcium and aluminium and silica. So it is also a combination of calcareous and argillaceous material. So now classification of cement. So cement is classified into 4 types based on the chemical composition. So cement is classified into 4 types based on the chemical composition. So one is natural cement, Aeronautical cement, slag cement and Portland cement. So cement is classified into 4 types based on chemical composition. So this based on this chemical composition classified into 4 types. What is that? Natural cement, Aeronautical cement, slag cement, Portland cement. So all these 4 cements, that means of this, Portland cement is the most widely used cement. Portland cement is the most widely used cement for construction purpose. So What is Portland cement? So it is most widely used non-metallic material of construction. It is the widely used non-metallic material of construction. So it is a mixture of calcium silicate. So this Portland cement is a mixture of calcium silicate and calcium aluminate. Calcium silicate and calcium aluminate with small amount of gypsum. So generally cement is classified into four types based on chemical composition. So what are the four types of cement? Natural cement, first donor cement, slag cement and Portland cement. So of these all these four, Portland cement is the most widely used cement. So what is the combination of Portland? How can you prepare this Portland cement? So Portland cement is widely used non-metallic material of construction. So it is a mixture of calcium silicates and calcium aluminate with small amount of gypsum. So the why we call this Portland cement? Why we call this cement is called Portland cement? Because the name Portland cement is used because this powder on mixing with water, the cement powder when mixing with water, it gives hard stone, hard rigid stone like mass which resembles to Portland cement. It is similar to Portland rock. So that's why the cement is called Portland cement. So Portland cement is the most widely used non-metallic material of construction and it is a mixture of calcium silicate and calcium aluminate and small amount of gypsum also we are adding for preparation of this Portland cement. So why we call this cement is named as Portland cement. So the cement powder is when we mix it with water, it gives hard stone-like mass which is resembles that means similar to Portland rock. So that's why this powder cement is named as Portland cement. So what are the functions of ingredients in cement? Generally cement preparation purpose we are using some ingredients. So what are the functions of all those ingredients? For example, lime. So already we know the lime is the most important constituent in the cement. So lime is the principal constituent of cement. So excess of lime, it reduces the strength of cement. That means it formation of clinkers or that means it formation of cracks. So if in case this lime percentage is excess or if this percentage decrease, in this case also it reduces the strength of cement. That means it forms cracks. So because it makes the cement to expand and disintegrate due to quick setting. So lime is the most important primary ingredient in this cement. So if this percentage increases or decreases, it reduces the strength of cement. That means it creates cracks. So it is mainly due to the quick setting of cement. So silica, it gives strength to the cement. If we are adding silica for what purpose? It gives strength to the cement. For example, alumina. So it is responsible for the setting action of cement. What purpose we are adding alumina? It is responsible for the setting action of cement. Excess of alumina, it makes to cement quick setting. If this quick setting means in this case also the strength of cement is decreases. So if we are adding alumina, so it is responsible for the setting action of cement. If in case this percentage increases means it makes the cement quick setting. So iron oxide. So it provides color, strength and hardness to the cement. If you are adding iron oxide, what is the functioning of iron oxide? It provides color, strength and hardness to the cement. Now let's go sulfur trioxide. So presence of small amounts of sulfur trioxide, it gives soundness to cement. Soundness means not exact volume, it changes the volume of cement. So in this case also reduce the strength of cement. So presence of small amount of sulfur trioxide gives soundness of cement. Sound means it will be proper value. Unsound means it is not exact values. It changes the strength of cement. So it provides sound. And gypsum, it acts as a retarding agent. Retarding means delay of setting. So this when we are adding gypsum, it acts as a retarding agent. So for quick setting of cement, that means it delay agent for quick setting of cement. If in case cement is setting very quickly, means in this case the strength is decreased. Minimum time it's required for setting. So it can be delayed by using this gypsum acts as a retarding agent. So these are the ingredients we are using for the preparation of cement generally. So lime, silica, alumina, iron oxide, sulfur trioxide, gypsum. We are adding proper amount of these ingredients in the preparation of cement. It provides strength to cement. So what are the properties of cement? So all Portland cements are hydraulic in nature. So when they are mixed with water, setting and hardening reactions takes place. So all Portland cements are hydraulic in nature. So what is the chemical composition of Portland cement? So this Portland cement is chemically defined as a finely ground mixture of silicates and aluminates of calcium of varying compositions. Generally, composition of Portland cement, here we are using generally the mixture of silicates, aluminates of calcium. They are presented various composition for preparation of Portland cement. So its approximate chemical composition is here. So what are the name of the boggy compounds, and what are the ingredients used for preparation of cement? So first one is dicalcium silicate. So what is the first ingredient? Dicalcium silicate. So formula is 2CaO SiO2. Dicalcium 2. Di means here. Dicalcium silicate. Shortcut symbol is C2S. So how much percentage present in this preparation of Portland cement? 25%. 25% of dicalcium silicate present in this chemical composition Portland cement. And second component is tricalcium silicate. Tri means 3. CaO SiO2 chemical formula of tricalcium silicate. So what is the symbol? C3S. How much percentage present in this composition? 45. 45. Next, third ingredient is tricalcium aluminate. Tricalcium aluminate. So tricalcium 3CaO, aluminate Al2O3. So symbol of this tricalcium aluminate is C3A. So how much percentage present in this composition? 10. 10 percentage. And next fourth ingredient is tetracalcium aluminoferrite. Tetracalcium aluminoferrite. So what is the chemical formula? Tetra means 4. Calcium oxide CaO. Aluminium Al2O3. Ferrous Fe2O3. So this is the chemical formula of tetracalcium aluminoferrite. Shortcut symbol is C4AF. Symbol of tetracalcium aluminoferrite is C4AF. So how much percent present in this composition? 9. 9% of tetracalcium aluminoferrite present in this chemical composition of Portland cement. And fifth ingredient is general common ingredient is calcium oxide. It is present in this composition 2%. And next one is magnesium oxide. Formula is MgO, magnesium oxide. It's how much percentage present in this composition? 4%. And last one is calcium sulfate. Calcium sulfate. Chemical formula is CaSO4. So how much percent present in this composition of Portland cement? 5%. So what are the ingredients used for this preparation of Portland cement? Dicalcium silicate, tricalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite, calcium oxide, magnesium oxide, and calcium sulfate. This is the average. It is the approximate chemical composition of Portland cement. Now let's discuss most important topic is setting and hardening of cement. Generally, cement when we mix it with water, this cement powder when we mix it with water, it forms a plastic mass. It forms plastic mass is called cement paste. When we are adding water, when we mix it with water, the cement, So in this case, it forms plastic mass that is called cement paste. So during hydration reaction, that means when we mix it with water to this cement, so during hydration reaction, so it produces what are the products? Gel and crystalline products. So gel means here it forms generally during setting and hardening process, it forms tobermonite gel. Tobermonite gel and calcium hydroxide crystalline products are formed. So cement, when we mix it with water, it forms a plastic mass that is called cement paste. So during hydration reaction, that means when we mix it with water, it produces gel and crystalline products. Gel and crystalline products are formed. That means during chemical reaction, during reactions in the setting and hardening process, it produces tobermonite gel and calcium hydroxide crystalline compounds are formed. So the insoluble gels and crystals, have the ability to surround inert materials. It's around ability to surround inert materials. So what are the inert materials like sand, bricks, crushed stones, etc. So the insoluble gels and crystalline compounds that have the ability to surround inert materials like sand, bricks, crushed stones, etc. So the process of solidification, that means this plastic mass of cement is converted to a solid cement. Solid cement. So the process of solidification means here plastic mass of cement, it converted to solid mass of cement or solid cement, that is called solidification. So the process of solidification, it comprises of setting and then hardening. It comprising of setting and hardening. So what is the meaning of setting? So it is defined as stiffening of the original plastic mass. It is defined as what is the meaning of setting? It is defined as stiffening of the original plastic mass. Original plastic mass due to the formation of tobermonite gel. Due to the formation of tobermonite gel. So hardening means it is defined as the development of strength due to the formation of crystals. So just now we discussed already. So when we mix it with water, the cement, it forms plastic mass that is called cement paste. So during hydration reactions, it produces gel and crystalline products. So the process of solidification is comprises of setting and hardening. So during setting process, it produces tobermonite gel. It forms tobermonite gel. When we mix it with water, this cement, so it produces tobermonite gel. So that is called setting. Hardening means it is defined as the development of strength. Here it is a setting means stiffening of the original plastic mass. You see this image, it clearly shows that setting. That means when we mix it with water to this powder cement. So in this case, it forms plastic mass. Plastic mass of the cement is formed. That means it is due to the formation of tobermonite gel. So next, hardening. So that means it is defined as the development of strength. See the difference between setting and hardening. Very hard material is formed. That means solidification. Plastic mass converted into solid. So here hardening means it is defined as the development of strength due to the formation of crystals. Due to the formation of crystals. So the setting and hardening of cement is mainly due to the formation of interlocking crystals. Formation of interlocking crystals reinforced by rigid gels formed by the hydration and hydrolysis of constitutional compounds. So when we mix it with water to the cement, it takes place hydration and hydrolysis reaction takes place. Then it produces then it forms tobermonite gel and crystalline products. Then in this setting and hardening process, it increases the strength of cement. So what are the reactions involved in the setting and hardening of cement? What are the reactions takes place in the setting and hardening of the cement? Setting means when we mix it with water, so in this case it forms tobermonate gel. And hardening means it increases strength of the cement. That means it forms solid, very hard material. That means a plastic gel mass converted to crystalline mass. That means solid cement is formed. It is called hardening. So total reactions, what are the reactions involved in the setting and hardening of cement? So this total process completed, it takes place 28 days. Time duration increases means the strength of the cement is increases. So first day one. So first day, when the cement is mixed with water, when the cement is mixed with water. So at first hydration of tricalcium aluminate. So the cement preparation purpose we are using tricalcium silicate, tricalcium aluminate, tetracalcium aluminoferrate, calcium oxide. So many ingredients we are using different compositions for preparation of Portland cement. So what are the reactions takes place in day one? Which one is hydrolyzed? So in this day one, when the cement is mixed with water, the first hydration of tricalcium aluminate. This is tricalcium aluminate takes place rapidly. Tricalcium aluminate when we mix it with water to the cement. So which one is hydrolyzed? Tricalcium aluminate takes place rapidly. That means within 1 day. So all the ingredients, which one is immediately hydrolyzed when we adding water, when we mixing with water, tricalcium aluminate within 1 day it can hydrolyze and the paste becomes quite rigid within short time. So which is known as initial set or flash set. Initial set or flash set. So here first day one reaction, which one is hydrolyzed? When the cement is mixed with water, in this case tricalcium aluminate. It is reacts with water, then it gives hydrated tricalcium aluminate. Hydrated tricalcium aluminate. It is immediate reaction, immediately hydrolyzed. That means it takes very less time. That means within 1 day. So this setting is called initial set. This setting is called initial set or flash set. So what is the energy of the cement paste? 880 kilojoules per kilograms. The strength of the cement is 880 kilojoules per kilograms. So this is the shortcut symbols of this tricalcium aluminate. When it reacts with water or mixed with water, it produces hydrated tricalcium aluminate and the strength of this cement is 880 kilojoules per kg. It is a crystalline compound is formed. It is a day one reaction. So next when we are adding gypsum, so in order to retard the rapid hydration, we are adding gypsum. Gypsum, what purpose we are adding? Mainly it acts as a retarding agent. That means it delay the quick setting of cement. That means it increases the strength of cement. So here in order to retard the rapid hydration of C3 tricalcium aluminate, that means early initial setting. So it can be avoided by adding gypsum. Initial setting is reduces or avoided by adding small amount of gypsum during grinding of cement clinkers. So gypsum reacts with tricalcium aluminate to give insoluble calcium sulfoaluminate complex. Gypsum reacts with tricalcium aluminate, then give insoluble calcium sulfoaluminate complex. So which does not possess hydrating property and retarding early setting of cement. So just now we discussed already what purpose we are adding gypsum to the cement. It acts as a retarding agent, a delay for quick setting. That purpose we are adding gypsum. So for example here tricalcium aluminate. Then it reacts with water, immediately it undergoes setting. So it can delay by adding gypsum. So in this case it forms calcium sulfoaluminate, insoluble calcium sulfoaluminate complex is formed. There is a day one reaction. Now let's go day 2 to 7 days. What are the reactions takes place? Which one is hydrolyzed? Between day 2 to 7 days. In day 1, which one is aluminate is hydrolyzed in step 1. That means day 1. Now let's discuss day in between. What are the reactions takes place in between 2 to 7 days. So after the hydration of C3 and C3S, tricalcium aluminate or tricalcium silicate, after hydration of these C3 and C3S, it begins to hydrate to give tobermonate gel and crystalline calcium hydroxide. So after the hydration of calcium, tricalcium aluminate and tricalcium silicate, it begins to hydrate to give tobermonate gel and crystalline products. So this is responsible for the development of initial strength of cement. It is the initial strength of cement. So the hydration of C3S, tricalcium silicates, it gets completed within 7 days. Tricalcium silicate hydration process completed within 7 days. So it does not contribute much to the strength of the cement. So what are the reactions takes place here? Tricalcium silicate, here are given shortcut symbols. Tricalcium silicate when started hydrated. So in this case it produces tobermonate gel and crystalline compounds, that means calcium hydroxide. So the hydration of C3S, it gets completed within 7 days, but it does not contribute much the strength of the cement. Now, what are the reactions takes place in between day 7 to 28 days? So in this case, which one is hydrolyzed in between day 7 to 28 days? Dicalcium silicate. Dicalcium silicate. It reacts with water very slowly. So in for day 1, immediately it reacts with tricalcium aluminate. Immediately hydrolyzed quick setting within 1 day. So it can be delayed by using gypsum. And next day 2 to 7 days, which one is hydrolyzed? Tricalcium silicates mostly. And it tricalcium aluminate and tricalcium silicate hydrolyzed to produce tobermonate gel and crystalline compounds and increase the strength of cement. That process tricalcium silicate hydrolyzed within 7 days. Now within 7 to 28 days, in between that, which one is hydrolyzed? Dicalcium silicate. Dicalcium silicate reacts with water very slowly and gets completed in 7 to 28 days. So this dicalcium silicate hydrolyzed, then it produces, then forms tobermonate gel and crystalline compounds, crystalline products. And what is the strength of the cement? 250 kilojoules per kg. So the increase in strength between 7 to 28 days is due to the formation of tobermonate gel and crystalline calcium hydroxide of both dicalcium silicate and tricalcium silicate. And finally, through the hydration of tetracalcium aluminoferrite. In first one, immediately reacts tricalcium aluminate. In second, 2 to 7 days, tricalcium silicates. And 27 to 28 days in between that, dicalcium silicate hydrolyzed. Then in this case, it gives tobermonate gel and crystalline compounds. The same way here, to the hydration of tetracalcium aluminoferrite in between that 7 to 28 days only, it takes place initially. The hardening takes place finally through crystallization along with dicalcium silicate. So here, this is the tetracalcium aluminoferrite formula. When it is hydrolyzed, it produces crystalline compounds and tobermonate gel. And the strength of the cement is 420 kilojoules per kg. So thus, the final setting and hardening of cement due to the formation of tobermonate gel plus crystallization of calcium hydroxide and hydrated tricalcium aluminate. So now let's discuss what is the difference between setting and hardening of cement. So first, setting of cement. Setting is a term. It is used for describe the stiffening of the cement plastic or cement paste. What is the meaning of setting? When we mix water with cement, we mix it with water. So in this case, the stiffening of the cement, it increases the stiffening of the cement. So setting is a term used to describe the stiffening of the cement paste. That means it forms plastic mass of the cement is formed when we mix it with water. That is called setting. So what is the meaning of hardening? It refers to the gain of strength of a cement paste. It increases the strength of cement. Gain of strength of a set of cement is called hardening of cement. Very hard resin material formed in this. That means plastic mass converted to solid mass is called hardening. Setting means plastic mass is formed when we mix it with cement, mix it with water. It becomes hard material. So that is called hardening of cement. That means solidification. Plastic mass of cement converted to solid cement. That is called hardening. And second point in the setting of cement, it refers to the change from fluid to rigid state. That means plastic to solid. So, and here hardening of cement, it refers to formation of solid mass. It possessing a good compressive strength. Good compressive strength. So the setting of cement starts 30 minutes. The setting of cement starts after 30 minutes from the instant when water is added to cement compacted within 10 hours. So immediate setting also there, it is known as the flash point or minimum point. Immediately when cement is mixed with water, after 30 minutes it is undergoes setting. It undergoes stiffening or setting. It takes 10 hours time or within 1 day this process completed. And hardening, the process of hardening of cement continue for a period more than 1 year. More than 1 year. So to know the setting of cement, initial setting time test and final setting time test are conducted. So in this setting of cement, the setting of initial setting time test and final setting time test to be conducted. We can calculate. We can consider the timings. But in hardening of cement, to know the hardening of cement, the compressive strength test is conducted. That means in this hardening process, generally improve the strength of cement. So we can consider how much it improve the strength. It can be calculated. It can be conducted. The compressive strength test is conducted. So these are the difference takes place in the setting and hardening of cement. So what is the final conclusion of this setting and hardening of Portland cement? So understanding the setting and hardening process of cement is essential for achieving the desired performance and durability of concrete structures. So mainly used for the understanding of setting. That means it forms a plastic mass and hardening, improve the strength of cement. That means solid cement mass is formed. Solid mass of cement is formed. For understanding the setting and hardening process of cement is essential for achieving the desired performance and durability of concrete structures. How much strength is increased by taking time in the setting and hardening. It is most important, the understanding of this process. So proper mix design, curing and quality control during construction are crucial aspects of ensuring optimal cement setting and hardening. It is most important in this construction. So in this session, we'll learn about what is a Portland cement, what is the classification of cement, what is the chemical composition of Portland cement, and what is the steps involved in this chemical reactions takes place in setting and hardening process of Portland cement. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.